My name is Philip Krantz. I'm one of the business developers of the Quantum Engineering Solutions team at Keysight Technologies. And today I will tell you a bit about the Labber, which is our premier software for controlling quantum experiments. And the Quantum Engineering Solutions team, so we are actually a part of, as you know, Keysight is a large company, about 15,000 employees. We are about 40 to 50 people within Keysight focusing on only quantum. And you can see the locations here. And what I wanted to point out here is that we have a few different acquisitions that we did within quantum. That's really been the seed for the team to grow. And the focus today would be about the Labber, which was a spin out of MIT. So when you think about Keysight, you might think about test and measurement equipment for various applications. And within quantum, we noticed that there's a big gap between the actual instruments that you use and the end applications that you have. And this is exactly what the software suite of Labber and Pathwave FPGA are about in the middle here. So the idea is really to enable small scale experiments up all the way to large scale scaling quantum systems and do that in a way that's easy for the end user. What every lab needs is an easy lab infrastructure that everyone can use. And this is a lot of reinventing of wheels around the world, that every lab needs to build lab drivers to be able to communicate with instruments. You need to run the experiments efficiently, and you need to analyze the data. And for industries, that often leads to launching a product or an application, or for academic research labs, you publish papers. So what Labber allows our users to do is that we have an infrastructure for this, so that individual labs doesn't have to spend a lot of time developing the infrastructure before they can run experiments. So this is more of a turnkey approach, where we have an instrument server, a measurement editor, and a log browser. So the way this looks like is the following. So the starting point is to connect all the instruments in the lab to the instrument server. And these instruments can be both real instruments, physical instruments, as well as virtual instruments. And these virtual instruments are really pieces of code that help the experiment in some way. And for those of you who are measuring on quantum systems, you know that you need to create pulses, you need to be able to demodulate data, and that there's a lot of functions in between the actual physical instruments that you need. So this is all taken care of here. And then you have the measurement editor, which is really where the cockpit of where you run the experiments from. And this is also very easy to use, that I will show you in a bit. And finally, the data ends up in a log browser. And this is really to organize the data and to make sure that everyone in the team knows what's going on and how the data was taken. So this is a great tool for not only analyzing data, but also to keep continuity in a team when you get new team members and when other ones leave. Finally, we have a Python API that can control all of this programmatically, so that you don't have to use the graphical user interfaces if you don't want to. So the instrument server is the starting point. This is really a list of instruments in the server, and the server handles communication across a lot of different interfaces. And it also does this in parallel, so that the communication between individual instruments is not slowing down the overall performance. If we take a look at one specific driver here, we have the multi-qubit pulse generator. So this is an example of a virtual driver that is used for qubit measurements to shape pulses. Next, when we enter into an experiment, what we do is that we add the instruments from the server, and we then import the instruments that we actually use for a specific measurement. And then we drag and drop settings from left to right. So this is a way to set up the scenario or to configure the measurement as you want. And then you set a log channel, so for instance, a digitizer channel or some oscilloscope where the data will end up. And then you give this file a name and you click start. And then you can follow the progress of the measurement in an easy way. So as you can see, this is a very fast way to configure a measurement and to run it. So it's very good for beginners or for people that don't have a lot of time. And that's a general trend in this business. Finally, we have the log browser. And this is where all the measurements, not only the data, but also the configurations end up. And in here, you can immediately analyze the data as it flows in, and you can do a lot of operations in here and export plots for logbooks or for even for publications. So if you want to know more about Labber, if you want to work with us, or if you have an application that you feel would be suitable for Labber, then don't hesitate to reach out to me. And you have an email address, and you can also find more information on our website about Labber. Thank you for your attention.
So it's great to see Keysight being not only just Keysight, but you can connect to other companies' test equipment?
Yes, that is correct. We recognize that every lab has a mix of vendors in the lab. So we feel that it's important from the end user perspective that we keep this open so that they are not locked into a corner of choosing vendors only to use it in the lab.
That's really great, especially with how fast the pace of quantum development is happening, right? So that's fantastic. Also, I know it isn't highlighted as much here, but I do want you to comment on, how you see FPGAs changing the game, so to speak. You care to comment on that?
Yes, of course. And this is actually one thing that, as Mark mentioned, this is not shown on this slide. This is a very high level flow of just how a workflow in the lab works. But if you look at advanced instruments such as the PXI instruments you have on this slide with an AWG, arbitrary waveform generator, and a digitizer, those instruments are very advanced in the sense that they carry FPGAs, which are lower level in the terms of programming. But what we have done with Labber is really to integrate the lower level functionality and bring that up to the Labber level so that our users can use advanced features without having to know how to program an FPGA.
It's also a lot faster than using a PXI backplane, right?
Yes, and it's very suitable for some tasks, in particular to speed up quantum applications. FPGAs are really key to do that.
Yeah, great. Thank you.